Hi there, this is Mrs. Whitaker from Bach North, and I am going to be teaching a lesson today starting with Unit 9, the very first lesson, which is 46, and it's on volume. Many of you coming from elementary should be aware of volume. You were taught that in 5th grade. It is the measurement to finding a three-dimensional shape, a solid figure, where you would need the length, the width, or the height and multiply them, and you could have to find the base times the height and multiply that. Let's start with the first part. Which of the following do you think is a perfect square? And you have to defend your answer. Well, looking at these, I see the one that looks like a perfect square to me is the letter C. So I'm going to put C here. And I ask you to defend your answer. So we have to give some reasonings. You could probably go back to 5th grade where you had to do the hierarchy for quadrilaterals and to know the definitions of them and the order in which they went, in which, if a square could be a rectangle could be a square, and so on. So if I look, I see a square, and they ask me for a perfect square. A square is a quadrilateral, so we're going to start off with defining it with a quadrilateral. You'll have to excuse my handwriting, it's not as good as Mrs. Linder. And what is a regular quadrilateral? It has the following attributes. It has 4 equal sides. It has 4 equal angles, which those angles are right angles or 90-degree angles. It's also known as a rectangle, but before that, let's also say that it has its opposite sides are parallel, which means the parallelogram. So also a perfect square can also be known sometimes, or a square can also be known as a rectangle. But we're not going to get into that right now. Some squares are described as a perfect. Let's draw a perfect square with an area of 9 units. So the whole entire shape should include 9 squares. So I'm going to go ahead and use blue, and we will count, make sure we have 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Again, it's not perfect, I'm sorry. And I'm going to outline it so you can kind of see. There's 3 across, 3 down, 3 across, and 3 down. And if you count those squares, it's a total of 9 with an area of 9. How do we ensure it was perfect, and explain? Well, we know it's perfect because the length is equal to 3 units. We know that the width is equal to 3 units. And if we remember our area formula for square, area equals length times width, and the length was 3, and the width is 3, which gives us an area of 9 units. And if you count all the squares, there's a total of 9 inside. We know it's perfect because the length is the same as the width. They're exactly the same numbers. What other dimensions would make a square perfect? List 4. So if I go back and remember what we said, that the length has to be equal to the width, we could say 2 is our length and 2 is our width, which actually would give us an area of 4. We would have a length of 4 or a width of 4, which would give us an area of 16 square units. We could do 5 as our length and 5 for our width, which would give us an area of 25 square units. Or we could do 6 as our length and 6 for our width, which would give us an area of 36 square units. So one thing I'm noticing to be a perfect, what they're saying perfect square, is my length is equal to my width. My length is equal to my width, and so on. A square has a length of 7. What is its area? So we just talked about a perfect square having the same length and the same width. So if the length is 7, then I know the width also has to be 7, which means my area then would be a total of 49 kilometers squared, because we're talking about 2 dimensions. Sorry if you couldn't see that. I was paying attention to my iPad and not my computer. Look at the next one, the area of a square. Now they're giving me the area. They're not just giving me the length, they're giving me the actual area is 64 centimeters squared. What is its side? So now I've got to think to myself, okay, the area is 64, and I know that has to be equal to the length times the width. And if we're talking about a perfect square, then I know these two numbers have to be the same. So what two numbers can I multiply? They're exactly the same. That would equal 64, which that would be 8 times 8. I always remember that. Plus, I came from elementary. The saying I ate and I ate and I got sick on the floor. So 8 times 8 is 64. So now I know that the length is equal to 6 centimeters. Now, why am I not putting the square there? It's because we were not finding the area. We were just finding the length of one of the sides. So we do not square it. Remember, a square has an equal size all the way around. Now you try it. A square has a width of 36. What is its length? Okay, so I'm going to draw my square out here. It has a width, of 36. And so what does its length have to be? Well, remember we said a perfect square. Both sides, the length and the width are equal or the same. So if the width is 36, then I know the length also has to be 36 feet. Thank goodness they were not asking us to find the area, because I do not want to multiply 36 times 36 right now. Look at the next one. Oops, sorry. The area of a square, now they're giving us the area, is 25 meters squared. What is the length? Again, if they're giving me the area and it's 25, I know that's equal to the length times the width, and I know if we're doing a perfect square again, that these two must be the same. So what number can I multiply? That's the same exact number that equals 25, and it's 5. So 5 times 5 is 25. That's a check. So the length is equal to 5 meters. Again, we're not finding area, so it's just meters. Next one. Think of a cube that is like a Rubik's Cube. What would you need to be true of the cube if it said it was perfect? Basically this side, or on this kind of question, we need to know that we have the same number of cubes. And yes, that sign means numbers, not hashtags. I don't know if you guys can see that, the way this thing is going. I don't think it is. I don't think you're going to be able to see it. So you have to just kind of fill it in. Sorry. Let me see. There, I can move it up there. Same number of cubes. And all the surface areas have to be the same. All surface areas have to be the same, have to be equal. So the length has to be equal to the width, which has to be equal to the height for it to be a perfect cube. Okay, let's go ahead and look at the back side of your lesson. Here's the back side. Some numbers are perfect cubes. For example, 27 is a perfect cube. If the number 27 is a perfect cube with a partner, find 4 other perfect cubes. I'm going to go ahead and have you pause the video. Ooh, I feel like Miss Linda right now. And see what you come up with. Okay, now you should be back from pausing the video, and let's see what you and your partner came up with. You could have come up with many things. In this case, this example, the length was 3, the width was 3, and the height was 3. 1, 2, 3 is the length. 1, 2, 3 is the width. And 1, 2, 3 is the height. So, which then, if you multiply all those together, 3 times 3 times 3, 3 times 3 is 9, and 9 times 3 is your 27 cubic units. So now you were supposed to come up with your partner with some other ones. You could have come up with 4 times 4 times 4. You could have come up with 5 times 5 times 5, or 6 times 6 times 6, or maybe you went lower and you did 2 times 2 times 2. What would need to take place for a number to be not considered a perfect cube? Well, that means that not all sides are the same. So you would write down all sides, or maybe all 3 dimensions are not equal. Which means one side could be more, or the length could be maybe 4, and the width could be 3, and the height could be 3. They could all 3 be different. The length could have been 4, the width could be 5, and the height could be 6. Let's go to the next part. State the length, width, and height of this figure. Again, it looks like a cube to me, but maybe not a perfect cube. If I look across, I see point. Here we go. The length is 1, 2, 3. The width is 1, 2, 3. And the height is 1, 2, 3, 4. So looking at this, I know that we don't have a perfect cube. It's not perfect, but we can still find the volume of it by doing length times width times height to find out how many cubes this figure has, which would be a total of 36. And how do I know that? Because I did the length times the width times the height, which would have been 3 times 3 times 4. These two give me 9, and 9 times 4 give me 36. Is there another way to find the number of cubes? Yes, we just said that, is to do the length times width times height. 3 times 3 times 4, which also gives me 36. The length and width is also known as sometimes the base, and sometimes students confuse that. The base is what it sits on in the very bottom, the first layer, and then you just take that first layer and then multiply it times how many layers they have, which would be 4 in this case. So sitting on the bottom would have been 9 squares, and then there would have been 9 plus 9 plus 9 plus 9, which gives you 36. What does volume mean? What you fill in there. It is a measure of the amount of space inside of a solid figure. Solid figure, again, has 3 dimensions. Kind of makes me think about the 3D movies that we see when we go to a movie theater. A regular movie has just 2 dimensions, just a length and a width, and it does not come out at you. But when you watch a 3D movie, it actually comes out and it has that 3rd dimension. Perfect cubes have a formula of V equals S to 3rd power. because of each side, S is the same value. So V equals S times S times S, S standing for sides. A perfect cube is a type of regular rectangular prism, so you can still use the formula length times width times height. So let's try it now. So it says find the volume of this cube. Well, we know that the length is 3. We know that the width could be 2 and the height could be 5. I know lots of students always ask me as a teacher, what if I mix up my width with my length or my height with my length? It really doesn't matter as long as you make one of the numbers or one of the dimensions an L and another one a W and the other one an H, and then you should be okay by the associative property. So now I'm going to multiply the 2 times the 3 times 5. When I work that out, 2 times 3 gives me 6. Then multiply it times that third dimension. So 6 times 5 is 30. It's where our unit is meters. And now we're talking about 3 dimensions. That's why we put cube here, cubic, that little 3. The last one, a pet store sold aquariums which have a volume of 21 cubic feet. So I know since it has that word cubic, I know they're giving me the volume. That's another clue I always tell my students. If they're saying square feet and they have a number next to it, that means they gave you the area. If they put cubic feet beside that number, then I know they gave you the volume. So you're finding one of the dimensions or all of them. They ask you what is the height, and I'm going to try to see if I can. Oh, I don't know. It's kind of let me. There it goes. If I do it like that, there we go. So I know that the 4 feet is my length. The 1.5 feet is my width, and I have to find the height. No problem, because I know my volume. So I like to always write out my formula first. Volume equals length times width times height, and I like to plug in my numbers, plug it in, and my volume is 21. My length was 4, my width was 1.5, and I still don't know my height. So I probably need to just go ahead and multiply the 2 dimensions I do have, which is 4 times 1.5. And I'm going to kind of do that out to the side here. This is my workspace. I tell my students I always put the ones with the most digits on top when we're multiplying, which in this case we have a 1 and a 5, 1.5, that has 2 numbers, 2 digits, and then I'm going to put the 4 in the bottom and multiply. And I always make my students make a line, and how many decimals do I have to bring out my decimal? 1, none here, and so I'm going to bring it back over a total of 1, and I multiply. 5 times 4 is 20, root my 2, 4 times 1 is 4, plus 2 is 6, and then I remember to bring my decimal over 1. And I have 6.0. So now I rewrite it as 21 equals 6 times the height. Now, at this point, you kind of have to think back to a previous unit when we learned about equations. And it might have been written maybe something like this, where they switched it around and they put 6h equals 21. And you had to solve for that variable h. You did that by getting rid of the number, not getting rid of the number, but undoing what is with the variable, which right now I know they are multiplying the 6 times the h. So to undo that, I have to divide. I have to do that on both sides. So now I can cancel out my 6's. And now I'm left with just h. So h is equal to, now remember also, Miss Linder always says a fraction is a division problem waiting to happen. So we have to divide 6 into 21. I'm going to work that out over here. Sorry. Move on over here. Into 21. 6 goes into 21 3 times. We have 18. You subtract. Let me erase this. You subtract with 3 left over. And now I have to add a decimal. Bring that decimal up. And then you're able to add your placeholder, your 0. You bring that placeholder down, and now you're going to divide 6 into 30. 6 goes into 35 times, and you get exactly 30. So now I know my height is 3.5. And what unit are we talking about? We're talking about feet. So yes, that one took a little bit of work, but that's okay. We knew the formula. We knew how to do equations, so we're set to go. Tonight you have to do the prep work that goes with this, and make sure you show your work, or there's no grading for that. So please show your work and just do not have an answer there. I hope this lesson helped you, and have a good night.